I'm working through this Johnson's approach where we're processing two different jobs kind of through the same conduits. So in our example 19.4, there's a grinding job shop and a deburring job shop. And what I have listed up here are the times that it takes to pass through each of those job shops. So each job and the amount of time in hours that it takes to process through that job shop. So step one was to create this table and determine these times. Now step two is fairly simple. What I need to do is I need to look in each column. I need to identify the minimum value in that column. And then I need to identify the minimum value in the next column. And if there were more columns, but I guess it only works if I'm passing through two machines, so I can't talk about more columns. Well, then I need to find, well, what's the minimum of those two things? Well, it's obvious looking at it, but I am trying to create a process in Excel that allows me to kind of revisit this with other problems, bigger problems. If I can, this is one thing about programming, if I can solve a problem for some toy little problem, it usually can be resized or rescaled to handle much bigger problems. That's why I keep pushing this. At any rate, it is job B that has this minimum processing time, and it's in the second column. Why does it matter that it's in the second column? Because if it were in the first column, I would use step 3A, but it's not. It's in the second column, so I use step 3B. And so I'm starting to line up my jobs, and what I do is I put B to the far right. Okay. So we now have one job in position, and it's going to be done very last. All right. Step 4 is to take this table and copy it, and then I'm going to remove row B because we've already assigned it. I don't need it anymore. So I'm actually just starting the cycle all over again. I remove row B. Once I've removed row B, I look for the minimum and what remains. I look for the minimum in column 2 of what remains. And then I look for the minimum of the minimums, and I see this coming out of column A, and it's process C. Process C is in the first process, so I go to step 3A, and I stick process C furthest to the left. So once again, I'm kind of getting my ducks all lined up. I'm going to do C first, I'm going to do B last. And then I repeat the process again. I remove job C with what's left. I find the minimum in column A. And then I find the minimum in column B. Then I find the minimum across the columns. And that is process E. Okay. All right, well, process E is in the second column, so I'm using step 3B, and I put E here next to B. Now almost all my ducks are lined up. I've got C, something, something, E, then B. Repeat, removing E, I have A and D left. I find the minimum. The minimum occurs in column A and in job A. So step 3A, A goes here next to C. Now I've got C and A, something, E and B. Now I could repeat step 4, but I've kind of got this little number theory thing going on, which is a pigeonhole process. D is the only thing left. It has to go into the last pigeonhole. So here I am. I have 5 jobs, and I have to push them through 2 processes, and they're kind of flowing at the same time. So I have created a sequence of events that will get my job done in the minimum amount of time. And that would be process or job C, A, D, E, and B. Hope this helps, and see you next time.